think it's time to get started, right? There's still people coming in, but maybe we just go ahead. All right. Welcome, everyone. I think this is the first session in this room. Let's see how this goes. You are all with me on the path now to full observability with open source software. And I am David. I'm director of user experience at Grafana Labs, which basically means you can either, if you get stuck somewhere, you can either shake your fist or you can write to me, and then maybe I can fix the button where you got stuck. And just to give you a quick outline of the talk, I'm going to give a quick intro of Grafana, then we're going to make an app fully observable, and then we're going to look at logging inside Grafana in a bit more detail. So first, quick Grafana intro. Quick question: who here is using Grafana? That's a fair amount. I'm quite happy to see this always. Doesn't hurt to ask. So what is Grafana? Grafana is maturing a bit. We have a light theme, so it's a bit easier on the eyes. We have dashboard folders now and a full-blown permissioning system. But more importantly, Grafana is also on a journey from dashboarding solution to a full observability platform. And at the same time, Grafana remains the unified way to look at a lot of data sources. And we're also on track to have all three major cloud providers as data sources built into Grafana. We're also working on version 6 quite heavily, which will have a new way to render multiple stats from the same group in a nicer way. And also we'll have means to cycle through different visualizations of the same query more quickly. That wasn't really possible before, and that's coming out in February next year. But I want to focus a bit more on the troubleshooting journey that you hopefully have, or hopefully not, I guess. It usually starts with an alert that you get in some kind of paging system or through Slack, and that alert hopefully leads you to a dashboard that then helps you narrow down with the help of ad hoc querying on where the issue could be sort of located. And the idea there is that you want to rule out a lot of things before you, so that you can kind of zone in on where the problem is. And when you've zoned in just enough, the idea is that then at this point you will consult your logs through some log aggregation system. And sometimes you might also need distributed tracing to debug latency issues, for example. And the general idea is that once you've sort of gone through all these motions, that you have a vague idea on what's going wrong, and that will also give you an idea on how to fix it. So yeah, Grafana wants to help you enable this whole journey. So what does that look like? We're going to instrument an example app. Let's look at a classic 3-tier app. You will have a load balancer at the top, a bunch of app servers in the middle, and 3 database servers that return the data to the app servers. And let's assume it's deployed to Kubernetes and it's running fine. Although, do we know it's running fine? I mean, who knows, right? The problem is it's not really instrumented yet, so we're gonna add this. And the first or the most basic form of instrumentation is usually logging. And because logging is quite important, you can think of what a log line represents. It's basically where the code path executed at this particular point in time. And if you have enough of those, you could theoretically piece together what your code was doing at which point in time. So the idea is also that logging is better than not logging at all, right? And then you can also kind of do the next step, that structured logging could be better than just logging. And in this example, we have a Golang app that where we're using a log formatter that comes with GoKit, and this will give us nice key value log lines. I'm going to show later how that's helpful. So on to metrics. What are metrics? or why are they helpful? So basically, if you looked at the log lines, you will have a difficult time to piece together, for example, a request rate or an error rate. I mean, you can sort of do the math, but it'll be much easier and if something else did this for you. And there are established metric systems out there, and Prometheus is one of those. And here's an example on how we can extend the same Golang app with a function wrapper around the HTTP handler that will give us the request duration for a particular handle path. And the last part would be to hook up Jaeger Tracing, which is also pretty straightforward for the Golang app. You just need to load the config, and then you hook it in as a middleware, and then it'll just magically work. I mean, it's not completely trivial to hook this all up together. So this is a really good set of resources to consult on how to get all these pieces working together, because somehow you need a bunch of exporters for Prometheus that will give you the right metrics out of Kubernetes, for example. Then we also publish our configs for running Prometheus and Alert Manager and Grafana together, and have all the paths match up nicely. And then the last link is a project where we're trying to encourage people to publish their own what we call mix-ins that should basically describe how their own apps will or should be monitored. So, for example, there's a Consul mix-in, or there's a Kubernetes mix-in, or whatever other apps you're using. Okay. So let's quickly run through a demo on the app that just before the talk started, I introduced a little error there. And so I need this back. And before I introduce the error, everything looked sort of green. Let me just zoom in here a little bit. And this dashboard follows the red method by Aaron Tombolki. We have the apps that come, or where the requests come in from the top. We also have those apps at the top. And then as they go lower down the stack, those rows should also be lower. So the request comes in through a load balancer, and then it hits the app, and then it hits the database. And in the happy path, everything's green, right? The latencies are nice and low, 10 milliseconds. I think that's pretty good. And most importantly, there's no errors, right? So, but I did, so you can also tell here, this was before I introduced the error, right? So now let's assume someone deployed something that was a bit, that had an issue. And let's narrow this down even further. And now we can already see two things happening. First of all, the latency shoots up, right? Before it was all around 10 milliseconds, and now we have 800 milliseconds in the 99th percentile. That's pretty long. That's quite the jump. So that's one issue, or could also be the same issue. We don't know yet. And then here there's some red, right? Red's not really good. So there's probably errors. Yeah, we can already see, because this is nicely formatted here, those are 500s. Okay, so somehow there are errors being produced by the database, but if we scroll up again, luckily, they don't make it to the app or to the load balancer. So the user isn't very likely seeing this as errors, but the latency is pretty high, and this will affect the impact of how your service is being perceived. And let's look at the latency issue first. And for this, I like to use Jaeger. So let me just quickly go there. And let's just quickly narrow down on what we're looking for. If you remember the latencies, they were around, they jumped up to 800 milliseconds. So let's just zone in on this. something between 500 and 1.5 seconds. And all right, let's just look at this example here. Top here. All right. So this is now a trace from that is producing a really high latency, and we can now step through how this distributed app was answering this request. Right? It came through the load balancer, and then it even made a request to the database, and this returned actually really quickly. But the app still somehow spent some time, right? And now we can ask more questions like why. What was happening. And I'm looking here at somehow this took 600 milliseconds, whereas the answer was somehow 50 milliseconds from the database. And this somehow leads me to probably some kind of 500 milliseconds delay. This is already where I'm using my brain. Basically from inside knowledge that I have about the application, right? And if I look at the logs, this just confirms it, right? There's a backing off period with which the app took before it was issuing a second request, which is this one over here, and this one then succeeded. So now the fix for this particular issue would probably be that the 500 milliseconds is a long time. The whole app could have responded a lot quicker if the backoff period wasn't that high. So this would probably be my fix for this particular issue. But there was a second one, right? There was a second issue where there were errors, right? So these are basically this red section up here, and now I need to figure out which parts of the database, I don't know yet, right? So I would jump to a new section of Grafana, which is called Explorer. This basically copies the query over to this new section, where I can iterate through the queries a bit more quicker, right? So I'm also in the right kind of time range because the error rates are non-zero, here the 500s, and but they're still summarized. So, but sadly, someone was using the alternate sum by aggregation. So I usually don't really know how to operate with this, but luckily this system should suggest the correct labels they can use. Okay. So now I'm gonna also break this down not just by status code, but also by instance. And just looking at the table, I can already see only one database instance is producing 500s. Okay, so this is good, because now I can just click and filter also by this one, and then just to verify, okay, well, this clearly produces non-zero. An error rate of non-zero. So I think I've zoned in on the correct instance. And now it would be really good to just look at the logs of this particular instance. So, and I can do this now inside of Grafana if I switch over to Grafana's logging. And, okay. There should be some logs. Okay, there's some logs. There should be logs that are failing that I'm just not seeing right now. So what we're doing instead now is let's just look at everything from this, and which also gives me an opportunity to show the user interface, basically. Let's just look at errors. So, there's something. Okay, and here we can see already the sort of errors that were being produced. And what we're also doing is In the browser, we're parsing the log lines, so we can also see not just what sort of errors were being thrown, but also the distribution here. So, and I can see, okay, there's a lot of query log timeouts, but also too many open connections. And this is now where I need to use my brain again to with inside knowledge of the application. And I know that probably the too many open connections are causing the query log acquisition error. And but this still helped me to figure out, okay, now I'm probably at the root cause with the too many connections, and the solution for this would very likely be to have more replicas of the database, for example, or I could use connection pooling in the app client when it connects to the database. Okay, so, and with these two fixes now in mind, I can deploy a fix, and I'm at the end of my journey. So, and just to showcase the logging a bit more, there's not just there's not just logging from this database component, but also everything else that Grafana's backend is running. It's, for example, because this data source is pointing to Grafana's internal system, and we're running Cassandra, for example. And I'm using this label selector language here that is similar to Prometheus. And if you remember what I did before, I was zoning in on the database and a particular instance during using PromQL when I was looking at the metrics, and then I was switching over to the logging system, and I was using the same labels. Yeah, and if you think of what a log line represents, it's not just the string, but Grafana's logging also attaches some metadata fields that we're indexing the log stream by. And for example, this Cassandra has a couple of instances, and I can also have a quick overview here on how that's balancing between the instances. All right. Here we also see that this is, for example, not structured logging, so we can't really do anything here with log line analysis. But if I switch over to Prometheus logs, for example, here now we have the log format, key value format, and here we can definitely parse all these keys for you, and then just give you the quick distribution across those possibly 1,000 rows. So you can do a quick in-browser analysis. All righty, so let's continue with this. So let's look at the logging a bit more in detail. Because if you're looking at your Grafana, you probably don't have this Explorer thing, and you definitely don't have the logging. So I'm going to tell you a bit more about this. We've been also internally looking for logging solutions, log aggregation, but we haven't really come across anything that we liked or was too complex. And other people on the internet had the same idea, or like had the same feeling, and this sort of got us thinking maybe we should just go ahead and write our own solution anyway. And then we got a bit more ambitious. Logs to be cheap, but not cheap as in bad or anything. But logs are actually quite precious, so you should be able to log a lot. And you should be able to retain this in a really cost-effective way. And also, we didn't really need full-text indexing because we thought just in-browser analysis on 1,000 rows should be enough if you can narrow down the search just enough. And so let's quickly revisit on what logging in the world of Kubernetes looks like. Basically, we're now in a world of dynamically scheduled workloads that have job labels attached, and but sometimes they go away. The pod goes away, the node goes away. So you definitely need some sort of log aggregation, because when the node goes away, you probably want to know what happened. And at that point, you can't anymore if you don't have a proper log aggregation solution. So this was step one for us. And then we also thought, there's already a system out there that does monitoring really well, and it's dealing with this dynamic world really well, and it's Prometheus, right? And the next step for us was to think, okay, well, why don't we just apply those same principles to a log aggregation solution? And we're the Grafana logging solution that I'm describing here is therefore heavily influenced by how Prometheus does the service discovery, how to find all the targets that are logging, and also it's taking its hints from on how labels are being used to identify log streams. And the biggest benefit then becomes if you're consistent with your Prometheus logging rules, and if you're applying the same, or if your Prometheus labeling rules, and if you apply the same labeling rules to your logs, then you can have the seamless switching that I showed earlier. So I guess I'm introducing Loki, which is Grafana's logging log aggregation service. It's there's an open source version and there's a hosted version, and we thought really hard about the name. We didn't really want to go with Greek gods, and then thought, well, Norse gods are kind of cool, but then someone on the internet said that. Anyway, at that point, we already had registered everything. Well, good luck. Well, this is the architecture. So central is the logging service, the Loki service, which ingests all the log streams. And on your node, you would need to install the Prometheus logging agent that's part of Loki. And in your Grafana, you just add the Loki data source. And when you have all these three components in place, then you can consume your logs through Grafana. All right, so the open source version is available. No, it's not available there, because I need to release it. So let's just do this right now. Yeah, it's still private. That's good. Let's make this public. Danger zone. Oh no, what's my password? All right, this worked. Cool, I'm really glad that worked. So there's also a hosted version, because we thought, like, well, why don't we just run this stuff ourselves also, so you don't have to. And it's still an alpha, but we're doing an all-you-can-log trial, whatever that means, which is going to be free until February no, Q2 is further than February. Yeah, so for a long time, or until it blows up. But yeah, we encourage you to try that out. All right, so one caveat. The log UI that you saw is behind a feature flag, which is called Explorer. So we need to go into your Grafana config ini and enable it there. And but in February, when version 6 comes out, we're going to release also the Explore UI, so that you don't have to do this particular step anymore. But you can use Loki already today. And if you look at the repo, there's also a command line client, which you can use to just look at your log aggregation. Yeah. So if anything there is not, if you're shaking fists again, just write to me first. Yeah. So what we're still working on, what we didn't quite get to, was to integrate tracing with this whole thing, because it would be even better if you could just switch not just from metrics to logs using the same labels, but also to traces. So, and we're working quite hard on making this also happen. And hopefully by the time the all-you-can-log trial runs out, we also have a new trial for tracing. So one last thing. Grafana has a conference, which happens in Los Angeles this year. So if anyone wants to join, there's a lot of dollars off if you use that discount code. And with that, Thanks for listening and democratize metrics and logs now. Cool. All right, I think we have time for questions.
Are there any plans to integrate with other logging services like the Elk Stack or Splunk or anything?
So yeah, so the question was, are there any plans to integrate with other logging services like Splunk or, yeah, so there are multiple answers to this. First of all, Grafana wants to be or wants to enable the existing data source plugins also to use the logging user interface that you saw. So we're currently building a logging model that can interact with these, right? So that you can still consume all the logs in there, and that you can, if you're happy with Splunk, that you can keep using Splunk, but you can do the whole troubleshooting journey inside of Grafana. Yep.
So you mentioned you had the aggregation pods in Kubernetes, and I think you said something about 1,000 lines. Can you talk a little bit more? Like, is that like a limitation of the aggregation layer?
Yeah. So no, that's actually the limitation that the browser or that we set in the browser query that we send to the backend. That we think is a nice enough data set to do in-browser analytics on. Yeah. But you can set this to whatever you want, right? But we thought it's really nice because you usually end up with response sizes of around 500K, and you can get those easily over the wire really quickly. Yeah.
So you mentioned the Prometheus as an agent that runs on notebooks for those logs. So what happens if, for example, I have a standard Elk stack and fluentd that enhances with metadata from Kubernetes? How can I do something similar to logging?
Yeah, so we don't have a complete answer for this, but for example, if you have the Elk stack already, and you, we will integrate with your Elasticsearch backend on the user interface level, right? Where we just send an Elastic query that comes back with logs and fields, and it'll be transformed into our internal logs model in the browser. And then you can consume those logs there. But your question was probably more around fluentd and...
Yeah, but it's the same. But if I now want to write a query, I write a logging query or Elasticsearch query?
You will keep writing the query language that pertains to the respective data source. So yeah, there's no abstraction around this. Yeah. Yeah. So we're trying to keep that separate. Like the interface you saw has those query rows in the top, and that's going to be determined by the data source. So Elastic, for example, or Loki, and then the result viewer. That's going to be the shared part.
There's no plans to have fluentd as another aggregator?
So I've been asked this question, and I've asked this question also internally to our developer teams, and there's no. Is there an official answer?
Well, we actually started off using fluentd.
Okay.
But the metadata delivery is not reliable enough.
Okay.
So that's why we had to write Prometheus.
So
Prometheus uses. So?
You guys are not supporting fluentd?
I mean, not in the open source code as it is, but there's no. If we can fix the problems with metadata delivery and fluentd, there's no reason why we can't.
Okay.
But the whole Loki story pivots so much around having this reliable metadata that we needed to have that 100% there.
All right, just to repeat this on the mic, the problem with fluentd that we faced was that the metadata delivery wasn't reliable enough, and that's why we brought our own prompt tailor. Yeah.
Should now, if I'm a user of Elk, should I will Grafana replace or override Cabana, my need for Cabana with Explorer and the dashboards?
So that's a question you have to answer yourself. Basically, Cabana with their discovery, for example, or their beats system, allows you also to write nice queries, and that works as well. And it has a lot more bells and whistles. But we try to deliver a lot like a more linear system with, I guess that's a bit more straightforward. At least that's our design goal. Yeah, but technically you can still use both, right? Because you will. I'm assuming you're running your Elastic and you have your Cabana in front of it, but you can also put the Grafana logging in front of it, and then you can the Grafana logging UI in front of it, and then you can benefit from both, right?
With Grafana becoming more and more customizable and configurable, is there any plans on moving towards some form of operator, having some custom resource definitions if we're to deploy this on Kubernetes?
So the question was, is there going to be a nice Grafana operator that deploys all the right parts, right, to Kubernetes? We don't really have one right now, but there was this setup slide that gives you all, or that at least shows you what we're using internally. And this is all based around JSONet. Are you using JSONet? Oh, okay, yeah. Yeah, well, maybe you just need to copy and paste some things, you know, but I can, yeah. We're heavily betting on JSONet and KSONet, and really happy with it right now.
I know you said it's a work in progress, but can you share the vision for how the distributed tracing will be integrated into?
No, not yet, because it will probably be something that is similar to, you know, when I clicked on, no, hold on. It'll be based on the data source switch that you saw at the top. You know, when I went from the ops tools to the Loki data source, and the idea is that the data source implements their own importers to figure out which labels exist on the data source that I'm about to choose, right? This is how the current switch is implemented. Yeah, so and this is logic that each data source needs to implement, and I'm guessing if we have a Jaeger data source or something like this, then this will be how it's going to be done. Yeah. But yeah, but the main goal will remain to use the labels to pre-filter the traces. Yep. Yep, over there.
Does Loki have support for like access controls and access with logs?
No. So we try to keep it really no frills. We have spoken to customers who are heavily relying on this because they are a bank or whatever. But for us, this introduces a lot of complexity that we don't want to burden ourselves or other people with, basically, yeah, at this point.
Can you repeat the question?
Yeah, the question was, will there be per log stream permissions? Well, that's the question, right? Yeah. Yeah, and the answer is not for the foreseeable future. Yeah, or maybe. I'm getting a maybe here. Yes, back there.
So, organization, what's your recommendation to ensure that metrics and logs are in a similar format? Because they're probably very different client libraries.
So, well. What I demoed was based on Prometheus and Loki, right? And you can use similar relabeling rules to ensure that everything's consistent there. Our story is a bit less clear on how this will work with other data sources, but I'm sure there will be documentation about this. Yeah. So I guess I couldn't fully answer your question there. Yeah. All right.
Can you talk about retention and persistence in Loki?
Yeah, so it's we're back, or the local version. You will need a Cassandra.
No, local's BoltDB.
Oh, what's?
BoltDB.
BoltDB locally on the on-prem version, which is, I guess, an in-memory inverted index. Is that true?
It's the same thing that etcd uses for persistence.
Oh, okay, so it's the same thing that etcd uses for persistence. And then the hosted version is backed by a chunk store for us. It's Google?
Yeah, Bigtable.
Bigtable and Google Cloud.
You can put the data in remotely. The index can live in Cassandra, Bigtable, DynamoDB, or BoltDB, and the chunks themselves logs data could live in S3 or GCS or on the local file system. Like it's pretty flexible.
Cool. I think that was it. All right, thanks everyone.